SPA software, so we can avoid this drafting work completely. So so by using this, software, we can develop most of the drawings in the software itself. As a designer, you are working on this software, and you are designing, as well as in the process you are developing these documents. In the process is developed because everything is formatted, and there are many uses of this instrumentation. SPI, smart plant instrumentation, powered by the InTools. They will call this InTools. So so it is developed by Intergraph. Presently it is known as the Hexagon. So with the software we will take this training also. So in this we have a different modules. So it is basically a networked software. So not only instrumentation, they have a smart plant, electric smart plant, 3D like that, mechanical, electrical, all the softwares are there. So they are all networked. So we can access the requirements of one discipline into another discipline easily. We can transfer the data, like process data we can get from process people directly, and also from our side the tag numbers and other things, cable numbers, everything, electrical people and other people, they can take. And so smart plant instrumentation software is there, but this software, as you know, it is developed by the Hexagon, and it is provided by them only. But we have softwares available in the internet, so we can use it for practice. So it is a test softwares are available. So using that test software, we can practice. So it is also nowadays it is picking up. It is a good for the upcoming engineers to have this practice on this, to know about this actually. So because everybody asking in the engineering nowadays, so experience with the SPI, smart plant instrumentation, or InTools they call this. So this also will go through it. So we had to develop a domain, and some administrative work is there, and so we had to develop the reference explorer is there, instrument index, that is a basically an instrument database. So we had to develop the database first. So database means instrument tag number, instrument loop, we can develop this. Then we have a browser module to browse the database, to have a different types of data available based on the requirements. Sorry. We have a process data module, so where process data is available from the process people for each pipeline. So for each pipeline, so we can have the when we are putting a instrument on that pipeline, whether a flow meter or a pressure instrument or a control valve, we can use that process data for the calculations as well as for the putting in the specification sheets. So that process data we are getting from the process people. Then we have a calculations module in the SPI. So calculations means, as we know in the instrumentation, there are 4 important calculations. So first one is a flow meter calculation. That is mainly DP type, orifice or venturi calculations are there. And so that is also available in this InTools SPI. And also second one is a control valve, sizing of control valve. So we are using presently InstruCalc. So that also we can do in the InTools software available. And relief valve is also there, pressure relief valve sizing also we can do here. So earlier we used to have a vendor software, so now we can do in the InTools only directly. And also thermowell selection. So thermowell is also important, especially for gas flow applications. So we had to size the thermowell. For size, the thermowell is very important. So this is also covered in this calculations module. Then all these things, specification module is developed. That is a specifications of each instrument, which covers the calculated data as well as process data. Both are transferred in the specifications module. So that is also important documents we'll develop in the process of designing. So as I told you, so here we need not go to, for drawings, we need not, wiring drawings, we need not go to the AutoCAD or anywhere. So wiring drawings also we can develop. That is a from instrument to the junction box to the system or marshalling rack, and marshalling rack to the system cabinet. So complete wiring we can develop in the InTools software. And by after developing the wiring, we can develop the loop modules, loop also. Instrument loop drawings also we can develop in the loop module. So if a wiring is perfectly done, so we can generate loop drawings, ILDs. So that is a important. So a lot of work is saved using this software. So that's why nowadays it is very popular. So smart plant instrumentation is a new development. So I request all the students as well as new prospective engineers so to know about this, and because everybody asking these things nowadays. So we can have a hookup module also, just like what in the conventional design we develop MTO, material takeoff. So we have a hookup module. So from hookup module, so we can have a hookup means nothing but instrument installation drawings. We can have a instrument installation drawing as well as material takeoff also you can develop in the SPA directly. So these are all related to the engineering. So what they claim is the intergraph people, they can use this for calibration as well as for maintenance using this database available. So calibration module is also there. So from the calibration module, so basically calibration module is a data entry. So you are doing, of course, in the laboratory using the calibration equipments. So that data you are entering into the software. So that is useful for analyzing for future. So calibration module also is there, and maintenance module. So once project is over, so what is the activity there? Maintenance. So maintenance schedules, so preventive maintenance, shutdown maintenance, and maintenance forms are there. All these things you can do from the SPA. So this is also important software. So this is all what we are covering in the process instrumentation and detailed engineering course. So the course
Arfaq,
objectives. Yeah,
can you give me Arfaq? Can we start a poll, a short poll here?
come again.
Can we start a short poll? We have a poll ready, so I'll just launch the poll.
Yeah.
Guys, I hope you are able to see this poll. There are 3 questions. I would request everyone to fill these questions here.
I will open another sheet in the meantime. Siddesh, are you there?
Hi, Shidesh is not there. Can you please continue?
Yeah,
I
yeah.
guess we have done with the poll. Yeah.
Yeah. So I will close this. So the first course we are discussing about this is a instrumentation and detailed engineering. So what we discussed is the 8 modules we discussed of different topics. So our course objectives we are discussing now. So the course objectives of this course is to make a learner to understand. So as we have seen in the polls, so there are students are there are professionals are there. So we can customize our courses topics also based on your, if you are a student or if you are a professional, you want some only some important topics, so that also we can selectively we can go, they can customize our courses also. So, but basically, the our courses, the topics are to understand the PID control philosophy. So, of course, the type of instrument selection, range, set point selection, all these things we will understand, and to understand the learners and the students. So the PID, proportional integral derivative control actions, and PID controller tuning also using the XLN software. Testing of instruments inline and calibration of instruments also you will understand, and operation of calibration equipment. So the dead weight testers like temperature calibrators also we'll discuss, and servicing repair using the, especially the control valve actuators, using the test equipment in the instrument workshop. That also we'll cover in this course. And so then testing of instruments in line calibration operations, selection of sizing of control valves, relief valves, flow meters. So as we have discussed, so we have using a software like InstruCalc or Fisher software for sizing the control valves, relief valves, flow meters. And next to the understand P&ID symbology, P&ID. So it is the engineering work as we discussed in the second part of our topics. All these things we can, the people will learn through these courses. Create and understand wiring drawings for junction boxes, control panels, and wire tape. Yeah. So select instrumentation cables, cable layouts. So this is an engineering activity. So that is called detailed engineering, which is in great demand nowadays. So because as you know, so a lot of engineering work we are doing, especially in India. So project may be somewhere in Middle East or some other place, but the design, the detailed engineering is done here. So a lot of work is there. So many people, especially in maintenance engineers, also wants to go into the engineering field. For them, this course is very good. So to create, how to create the, understand the wiring drawings, junction boxes, all these things we'll discuss. Select instrumentation cables. This is we discussed. Understand the standard instrument installation drawings. As I told you, installation drawings are important. From there, you are preparing the material takeoff and so design using the smart plant instrumentation also we are covering here. And this is important. Nowadays, everybody is asking about SPI. So if something is there in your CV, that is a very good for your job prospects. So we have to prepare specifications, and IO database is also important. So all these things you are going to learn. These are the objectives of our course. So about this. So friends, this is about this first course. Second course is automation. So now we are going to the automation systems. That is the industrial automation systems. So I will go to the next slide, industrial automation. Friends, can you see this? Yeah. My new screen, can you see this? Siddesh? Yeah. Yeah. So this is a industrial automation systems and panel design also we are covering this course. So industrial automation systems. So as you know, there is a many industrial automation systems out there. So right from RTU, remote terminal unit, PLC, DCS, ESD, FNG, fire and gas system, FACP, fire alarm systems are there. So many systems are there. So these are all comes under industrial automation systems. So there are similarities in all these activities, in all these systems. So, and also we require a panel design for this. So these things we'll discuss here. Now in this first one, so module 1, we are covering in this introduction to automation systems. So we'll take one example because we cannot study everything at a time. So one important automation system is a PLC, programmable logic controller. So as you know, most of them, it is a programmable logic controller. So it is a basic control system or automation system for any industry. So like manufacturing or process industry or even machine industry also they are using this. So as I told you, all automation systems are somewhere they are similar. So but they will different based on the depends on the complexity, types of IOs, number of IOs, type of interfaces. So these things we'll study in this automation, industrial automation systems. So, but first we'll start with the PLC, introduction to the automation system, that is using the PLC. So first we will discuss what is automation, its advantages in process industry. So process industry, what is it? We will start from the basics in this course. Introduction to the PLC and its role in automation. So we'll start with the PLC. So what is this? So using the Allen Bradley PLC. So we'll discuss this. So fundamentals. PLC fundamentals, like a block diagram of PLC. We'll discuss what are the inputs, what are the outputs, what is the controller functionality, that is a CPU functionality, and also interface with the SCADA or other systems. So that is a PLC fundamentals. So here also we are using a sample PLC, Allen Bradley PLC, which is very good for understanding, and PLC logic development and programming. So this, as you know, so every industry will have some logic. So what is that logic? So when to start a pump, when to stop a pump, or when to move a sensor. All these things comes under PLC logic. When to stop a conveyor. So all these things comes under PLC logic development. So as a designer, so you should be able to develop the logic, and that logic will be developed, actually programmed by the PLC vendor. Or of course, you can also do as a, if you understand the Allen Bradley or S logics, we'll use the here for the programming purpose. So as you know, PLC logic development means logic function blocks will start from NO, NC contacts, NO contact, NC contacts, timer block, and counter blocks, and many other algebraic blocks also will use here for developing the program. So that will give a clear idea about your automation system programming. And we'll discuss some important field devices also attached to the PLC, especially the contacts. So contacts will simulate, because on the trainer we have a simulators like switches, and outputs is for relays and lamps we are using, and also analog signals also we are simulating, analog input as well as analog outputs we are simulating, and power supply, CPU, IOs, communication bus, all these things we'll discuss here, and wiring of devices also we'll discuss here. So that is the beginning of this course. So we'll try to understand what is a PLC. So this is a PLC we are having. So through this, so this is a CPU, Allen Bradley CPU is there, and we have a simulators here, inputs and outputs. Inputs and outputs are there. There is the analog simulators also there, analog signal simulator, analog output reader, and this is communicating with the programming terminal is there, and there is a simulator here, batch controller. So by programming this, we will run this, and we'll show this, all these things in the training. Then in the second module, automation systems, other automation systems. So here we'll discuss a general block diagram and applications of DCS, ESD, as I told you, distributed control system, emergency shutdown system, PLC, programmable logic control, RTU, remote terminal unit, SCADA, and FACP, FNG, as I told you. These are the different automation system, but they have a common features. So we'll discuss these common features, and also we'll see the differences also and applications also. That is important. So for automation system, architecture will develop, especially for the DCS. So architecture means basically it is a network, and nodes, how they are connected through the nodes. So this is a sample of this DCS system. We have a marshalling systems, marshalling racks, and the center we have a DCS system. We are going. Yeah, as I told you. So now we are going into a different system. This is a system architecture we'll study. So for DCS, we'll take example of Ekogawa CS3000 system, and we'll study that because DCS is a huge topic, so we cannot go generally irrespective of vendor. So we have to follow one vendor. So that is a Yokogawa CS3000 will follow. Using that model, we'll see the architecture and the IOs, the networking details, all these things we'll discuss. So then we'll discuss field and system enclosures. So to install these systems in the enclosure, so we have to do the system engineering. We call this as a system engineering. This also we are going to learn. So it is based on what? Based on the IO list, what we are preparing in our previous course. That is a process instrumentation and detailed engineering. So in this, the IO list. So as a designer, you are in the right position to prepare all the inputs and outputs connected to your automation system. So that is the IO list we prepared in the previous course that we are using this. So it has become a database actually. So this database is used for further in the system engineering for the terminations, for the cables and all details we are entering in this database. And based on the IO list, we'll do the system engineering. System engineering is basically selection of these IO modules. So how to select that? So based on the number of IOs, of course, is important, and the types of IOs also important. So based on that, we will select this. We'll do the system engineering, and then enclosure rating also important. So enclosure ratings, area classification we'll see first. So based on the area classification, whether it is a zone 0 or zone 1 or zone 2, so we'll select a proper enclosure. So that also we'll study in this module, that is called the enclosure rating. And especially oil and gas fields, this is very important. So based on the IO modules, we have a power and heat rise calculations also. So here also we are using the software to develop the power, how much power is required for your cabinet. That is very important. So that is based on what? Based on the number of IOs, number of modules in the cabinet. So that is an enclosure rating.
Excuse me, Arfaq.
Yeah, come ahead.
Yeah, Arfaq, your screen is frozen. We cannot see anything.
So 1 minute.
Maybe if you can stop the share and start it.
Yeah. Yeah, can you see this, Siddesh? Can you see this, friends?
Yes. Now we can see.
Oh,
actually, your screen was.
Okay. So it's not much a problem. So yeah, now can you see this? Yeah.
Yes.
Yeah.
This industrial automation system, yeah.
Yeah. So we started with this only.
It's visible. Okay.
So
Thank you.
Yeah. So we are discussing this module. So module 1, that is the introduction to the automation system, that is a PLC. So then next we are going to the this trainer where we discussed. This is a trainer. Through this trainer, we are giving the training. So here Allen Brodie PLC we are using. So it is a complete trainer. So using a similar PLC simulator, we will train this, give this training. So then then this third one is now we are going through it. So after discussing about all the other systems like DCS, ESD systems, and FNG systems, we will come to the field and system enclosure. So as a designer, so you have to design the enclosure also. That is a housing for installing your PLC or any DCS system. So field and system enclosure. So it is based on IO list as we discussed, and PLC system engineering, that is called system engineering. So based on that, we are selecting the modules and we are doing some calculations also, power calculations. So how much power is required by your cabinet. So that is important. So that also, as a designer, we have to develop this power calculations, and when based on the power, how much power it is consuming, there is a heat rise in the inside the cabinet. This is also important. So this heat rise calculations also you have to do to ensure that the temperature is not going out of hand inside the enclosure. So especially if you are installing the cabinet outside, so these heat rise calculations are very important. So if you are installing the cabinet inside the control room under AC, no problem. But if you are installing outside, so these calculations are very important. Basically, you are ensuring that all the components inside your system are suitable for that particular temperature. So that is ambient temperature plus heat rise, temperature due to heat rise. So these things we are discussing in the second module. So this is the architecture we are discussing about this. Now we are going to the DCS system. As I told you, based on the Yokogawa CS3000, we will discuss the basic components of DCS. DCS architecture and configuration we will discuss here. So DCS architecture is very important. Basically, it is a network. So we have a primary bus, we have a secondary bus, and through nodes we are connected to different components, field control stations, as well as so operator station and engineering workstations we are connected. So that we'll discuss in this. IO modules also we'll discuss. Different types of IO modules, wiring and marshalling philosophy also we'll discuss. So normally in the DCS we use a marshalling cabinet, so that the EPC contractor will end up with the marshalling only, and from marshalling system up to system side, DCS vendor will take care. And also the cross wiring between the inside the marshalling also taken care by the vendor, DCS vendor. So that's why they will use a marshalling philosophy, and graphics development and alarm management is also important. There is a workshop to be conducted for alarm management based on the process requirements, of course. So all these things we will discuss in this module 4, that is a DCS, distributed control system. So we'll see the difference between PLC, DCS, SCADA, ESD, and like that. We have a differences are important. So for a smaller plants, we can use RTU, remote terminal unit, which is a for a small plant. So involving some 10 to 20 IOs maybe. PLC for a bigger system, like 25 to 30, 50 IOs. DCS is a complete system. So for a very complex processes like distillation tower, that is a refinery, power plants, gas oil separators. So we'll use this DCS system. So DCS is a complete system. So we'll have a all types of, so especially meant for logic as well as analog configuration, and graphics development is a advantages in this. All complex controls like distillation tower, 3-element control, all these things we can do very easily in the DCS system. So these things we'll discuss in the DCS. So after this, we'll go to the other system, that is a ESD. So this is a PID controller tuning also we can do very comfortably using the DCS systems. Yeah, instrument faceplate, as I told you. So these are the instrument faceplate we can see in the DCS graphics. So we can develop easily. That is a specialty of a DCS system, to develop the different types of graphics easily. So the softwares are very strong, and so we can develop different types of graphics, both for the operation as well as for the engineering work. For the instrumentation work, we can develop this controller, and using this we can tune the controllers very comfortably, and we can store all the data related to the commissioning. So we can store all this data also. So this is a sample of this instrument faceplate. So yeah, now the emergency shutdown system. Sorry. Yeah, so ESD is an emergency shutdown system. Emergency shutdown system. So this is also important, especially for the critical applications. So for this, we have to study the required protections systems in the industry. So you can see this figure. We have a different protections. Basic process control system is there, that is like normal DCS. So we have a normal behavior. So the idea of ESD is will be coming from here, but this is a first protection is a, or first system is a basic process control system, BPCS they call this. So this is a normal PLC or any DCS system which will have a process control. Process value is maintained, normal behavior, process control layer. So we have a process alarms also. So that is in this value. So next comes operator intervention. That is a process alarms and shutdowns. So process control layer, still it is a process control layer. So we have the safely we can have a process alarms will come. So operator can take a corrective action, and if required, he can shut down a plant for the safety of the plant. So if this is also not suitable, so we have a trip level alarm system. So there the safety instrumented system is coming into picture. So that is an emergency shutdown system. So that is it comes under safety layer. So this emergency shutdown system is a important system for the safety of the plant, safety of the structure. So this is important. So emergency shutdown system is meant for safety of the system. Maybe you are losing a production. Maybe your production will come down, but for safety of the equipment is important. Safety means, so for example, if you are driving a turbine, so turbine temperature, bearing temperature, vibrations are going out of control. So you have to shut down the plant, shut down the turbine. So by using this emergency shutdown system, we are isolating that turbine by closing the inlet valve. So that is a safety of the system. Safety is important. So otherwise, if you are running without a shutdown, so turbine may be damaged, and for a longer periods of time, so it will be out of construction, then we will have a more loss of production, maybe 3 months or 6 months. So here idea is safety of the equipment is important. Safety of the equipment as well as safety of the personnel. So that's why ESD system is very important. So we have in the boiler safety system. So that is in terms of boiler, we'll call this boiler management system or FSSS, furnace safeguard and supervisory system. So it is also ESD system. So we have to make a study of this emergency shutdown system. So all these things we'll study in this ESD system. So if you study the protection layers, so after the ESD system, we have a protection layer, that is a relief valves, rupture discs. So if this also is fails, so we have a protection, active protection layer. So there is a relief valve will open to prevent pressurizing of the vessels and pipelines. So then it is a mitigation. So this is not our job actually. So mitigation is by the management actually to mitigate the reduce the losses or prevent the further damage to the system and people around them. So here this layer is a emergency shutdown system is a requirement of this system. So emergency shutdown system, we have a complete module here. We'll describe the purpose of ESD system here. So that means we have to study the hazardous requirements and we have to decide the ESD type. So we have a many ESD systems. So there is a SIL requirement, safety integrity level studies are there. So we have to make a study and we have to decide which type of ESD system is required. It is called SIL 1, safety integrity level 1, SIL 2, SIL 3, like that. So describe the typical ESD applications. So we'll discuss the basic applications also. So here describe the basic ESD system and functions of it and its components we'll discuss here, and define the industry standard requirements. So we'll study the standard requirements, that is the specifications of the ESD. So as I told you, so we have a standard specifications. Every engineering company will have every system will have a standard specifications, written document in a Word format. We have a standard specifications. So all the vendors will follow this. So like this, standard requirements we'll study here and describe the ESD system logic types and typical ESD system architectures also we'll discuss here. So logic types, as you know, different types of logics are there. Energized to trip or de-energized to trip we'll study here. So normally it is a de-energized to trip philosophy here. So here the philosophy is normally we will use a NC contacts, normally close contact, because it's a protection system. So if a contact is broken, that is a NC becomes a NO, normally open, normally close will open, then we'll have a ESD action. So we have a ESD logic systems also we'll study here. And so this is a complete ESD requirement. So this is important for especially for the professionals. So who want to know about the ESD systems and DCS systems, who are familiar with PLC, but they want to introduction in the DCS systems and ESD systems. So they can go through these courses. So as I told you, for depending on the requirement of a person, learner may be a student, maybe a fresher, maybe a professional, maybe experienced man. So if you want to know about this, so they can contact us. So we'll make a customized courses for this particular systems, and we'll definitely will take that. So after this ESD system, we have a FACP system. Another system we'll discuss in the automation systems. So FACP, fire alarm control panel, FACP. So this is also important, especially for the buildings. So the control rooms, the battery rooms, the PAB, process interface buildings. So we need a FACP, fire alarm control panels are there. So we have a separate course for this also, fire alarm control panel. So we'll start with the introduction, FACP. So so we'll start with the types of fire alarm detectors. So as you know, there are smoke detectors, there are fire detectors are there are pulse points are there, many types of detectors are there, and depending on the application, there is a capacitance type, there are ionization type, like different types of detectors are there. So we'll discuss about it first, the selection of the detectors, then the type of fire alarm systems. So addressable system, analog systems, and non-addressable systems. So there are different types of fire alarm control panels we'll discuss here. So fire alarm control panels. So of course, non-addressable are outdated. So we'll not just, it will be introduction only. So presently addressable systems are there and analog systems are there. So in that we'll discuss the types of wiring, types of cables also we'll discuss. And commissioning and testing of fire alarm systems also we'll discuss here. And fire alarm system management is also important. So especially this standards and testing procedures, the factory acceptance tests. So all these things are there. So how to conduct this, all these things we will cover here. So we have a fire alarm system design concepts. So basic design concepts also we'll discuss here. So there is a fire and gas system is also there, especially in the plant area. So we have a fire system as well as a gas system. So actually, so fire and gas, FNG and FACP. What we discussed just now is a FACP. So FACP and FNG systems are similar, of course. FNG is for the main plant. So because FACP is a fire alarm control panels, what we discussed is a for the buildings, control rooms. So now fire and gas system. So as you know, in the especially in the classified areas, it's a very risky to have this fire because it will cause further explosions. To prevent it, so we need a fire detectors, gas detectors also. Gas detectors also is there. So to prevent ignition in that, so we have to ensure that there is no gas leakages, fire and gas. So for fire and gas, there is a separate system, FNG system, we call this fire and gas system. So here also fire detectors also important. So here we'll discuss the fire detection. So as the block diagram here shows the fire detection. So by the smoke or by the heat or by the flame or manual call points are there. These are all fire detections. And gas detection also important, especially in oil and gas fields. We have a toxic gases like hydrogen sulfide, which is a very serious toxic and also flammable gases, that is a combustible gases. So there is acoustic leakage, manual call points are there. So mainly toxic gases are hydrogen sulfide, like that, NOx, like that gases are there. That also we have to detect it, and we have to, we will cause the shutdown of the plant if required. Flammable gases, that is related to the combustible gases. So combustible gases, it is identified as a LEL and UEL. LEL means lower explosive limit. So how you are going to fix the LEL, and UEL, upper explosive limit. So based on that, we have a LEL and UEL detectors also. So we have to decide this type of gas detection, and all this coming to the logic solver. This is nothing but a PLC again. Logic solver is a PLC. So maybe ESD system, and it is driving the outputs like notification appliances, like beacons and horns. It is driving the beacons and horns, alerting the people so that people should not come near because there is a gas leakage, or there is a toxic gas or flammable gases are there. So these are, it will drive the notification appliances like beacons and horn. And also fire suppression systems are there. Safety shutdown system, it will drive the safety shutdown system through ESD system. So this is a block diagram, and like that, alarm lists, alarm displays are there. It will go, it will give command to the switchgear system also for shutdown of a particular auxiliaries like big pumps, compressors, like that. So these are all coming under FNG system. So this module 7 completely we are dealing with the FNG, fire and gas system. So fire and gas definitions will start with, and as we discussed, fire and gas system block diagram and architecture also will study here, and how it is related with main control system also we'll see here, and fire and gas detectors also will selection also will study here. Fire and gas detectors layout, that is also important. Just like our instrument layout, we have a fire and gas detector layout also is there. Then safety certifications also important. F&G is a safety system, so comes with a safety certification. What are the modalities here for the safety certification? This is also important if you are working as a designer. So this is also important. And this is about the F&G system. And the last one is a intrinsically safety systems. So this is also important study actually. So intrinsic safety system and hazardous areas. So again, we'll discuss about the hazardous areas here. So we'll define the American system as well as that is a NEMA based, and also IEC based, that is a European standards we'll discuss. So there is a division system, there is a zonal system. So we'll discuss both and we'll try to correlate it, because so as a designer, as a material procurement, you will get vendors from European or American. Will have a both. You have to be able to compare these two things also. So those hazardous areas we'll discuss, and when it comes to zone 0 system, so you need a intrinsic safety philosophy. Intrinsic safety, what is intrinsically safe systems? That is important. So here, intrinsically safety barrier, this is a simple block diagram is there. So we have a control system which is in a safe area, and especially in a marshalling cabinet, we have a IS barrier which will control the current to the field devices, which is in classified area. So this is IS barrier. We have to select and size this, and this is important here, and this philosophy is important, and so we'll study the intrinsic safety system here, like spark ignition characteristics. So that also we'll study here. Explosive limits we'll study here. Classification, equipment, gas and temperature. So that is a classification equipment. So what is the gas and temperature? So all these things. So what is the zone 0? And what is a temperature classification, what is a gas classification, that is a grade. So we'll study that, which will be marked on the system. Yeah. Method of explosion protection also we'll study here. And intrinsic safety, see the definition, and intrinsic safety barriers we'll discuss here. So how to select it, and intrinsic safety calculations also involved here. So it is also being done in the tools also, smart plant instrumentation. So intrinsic safety calculations based on your cable length and also your barrier and instrument, field instrument. So all this is a study. It is a very good study, especially for professionals. It is a good, so they can have a, by learning this course, they will have a good understanding of this intrinsic safety, which is an important requirement in an engineering field. So these are the things we are covering in automation systems. And coming back to objectives. So as we discussed in the courses, in the topics, the objectives of this course is to make a learner to understand. So as we discussed, industrial automation systems. So logic development and PLC programming. So that is what we are starting from. IO database, system panel design also we will understand based on the IO list. Power and temperature price calculations, this is also important based on the system design. Enclosure rating, NEMA or IP ratings. Of course, we will study first hazardous areas. Based on that, we will decide the NEMA and IP ratings. And different automation systems, so we'll discuss right from RTU, PLC, DCS, ESD, and we'll do the comparison also for which system, which industry, which system is good and which is a requirement we'll study here. And DCS architecture we will understand, and configuration also you will understand. ESD, basic ESD system and functions and its components. So ESD system, as we discussed, a complete one module is there. So you will understand types, logics, everything. Fire and alarm systems, fire and gas systems, both are of course related. FACP is for the buildings and FNG is for the plant area. So this is also safety system. Finally, the intrinsic safety barriers, their calculations, you will understand in these things. So these things, our objective is the learner can understand and he can understand these things. Some people are chatting, so I will try to see. Yeah. Please solve the issue. That is, I have solved. Navedi, well, I think the screen was not updated. Type message here. So it is a slow So friends, if you got any questions, please go ahead, because we are coming to end our required time.
Guys, does anyone have any questions for Arfaq? Or the post-mortem or anything that you're going to understand?
Hello friends. So this is what I wanted to tell you about my two courses we are going to put in the lab docs or these things. And that is the first one is a process instrumentation and detailed engineering. And also, of course, it includes the SPA also. And the second course is a automation systems and panel design also. So anybody got any questions, you can email me. There is an email is there already. And or you can ask me any question, no problem. Anytime you can ask.
Great. Irina, are you able to hear me?
Yes, sir. Hello. Yes, sir.
All right. Okay. So, Arfaq, I think we have come to the
Yeah.
end of this session, right?
Yes, yes. So that's what I wanted to talk about these courses. Yeah.
All right. Okay. Sure. So, thanks a lot, Arfaq, for sharing all these details, and I'm sure that
Yeah.
we all are looking forward to joining your programs, and some of them will be available soon on LabDocs.
Yes.
And this is really going to help students, and there's going to not students can be anyone. No, it's not necessary that you have to be a student or graduate. It could be any professional or who was looking to acquire a new skill in
Yeah. Yes.
instrumentation and
Yeah.
control. So it is going to be really good for a betterment of their career, or
Yes.
for betterment of their career and growth. So, with this, guys, we have come to an end of not only this session but of this conclave. We had a really good time, and I hope you all have managed to get some value out of it. And if you have done it, so I would request you all to share this in your social channel. You can share it with your friends. And some of the sessions have been recorded, and our registered participants are going to get a copy of that, a replay of it, so that you can enjoy it whenever you like. Those who have taken workshops, it's going to be put in our LMS, and you will soon get to know about it. So, with this, we come to an end. It was a very fruitful 2 days conclave, and we got to learn a lot many things. We are going to come back to you pretty soon, and we are hoping that we are going to create a very good buzzword or brand name for this event. So, with that note, I would say bye, a bit adieu to you, and I'll hope that you guys are going to take care and stay safe. So, thanks a lot, Arfak, and those we have already shared the coupon codes during the start of the session. I think when Arfak was still joining.
Oh,
So
yeah.
if any one of you have not yet received, we are going to share it one more time here on chat. Yes, so we just did that. So guys, you can take use of these coupons, and you can enroll for the courses on Udemy. Some of them are for free, and some of them are heavily discounted, more than 80% of discount you could find. So thank you, Arfak, for doing this for our learners and for our community. And we are sure that
Yeah.
we are going to create a lot of value for everyone in the future.
Yeah.
Thanks a lot,
Thank you so
guys.
much.
Bye. Bye for now.
Bye. Thank you.